Hey everybody, this toolkit is for Unit 5, Lesson 1, Investigation 3, Expanding the Quadratic Expression. Okay, so what does this look like? Or what does expanding mean, really? And that's when we're using the distributive property, to multiply one set of parentheses over another set of parentheses. So we'll of course look at a couple examples, but basically what that means when we multiply one set of parentheses across another set of parentheses is that we're going to take everything in one parentheses and we're going to make sure that it's multiplied by everything in the other second set of parentheses. So let's see what this looks like. Let's look at a very basic example. We're not going to put any numbers in here. We're just going to talk about kind of in theory what's going on here. So here we've got two sets of parentheses, x plus m and x plus n. And if I want to expand this, I'm going to take my x times my x, and I'll get an x squared. I'm going to take that x and also multiply it by the n, so that would give me nx. I'm going to take this x and multiply it by my m and get mx. And then I'm going to take this m and multiply it by n and get mn. So what I've done there is I've made sure that the x in the first parentheses multiplied by everything in the second set, and the m in the first set of parentheses multiplied by everything in the second set. Now, if we had numbers in here and we had our nx and our mx, let's say it was 3 and 5, 3x plus 5x, what we would do is we would take these two things and we would add that n and the m together. And then we would say, since it had that common factor of x, we would just multiply it by the x still. So we would still do that here. So we're still going to add those two things together, but then we also have to carry everything else from our expanding down as well. And it's nice to see that the relationship that we have here is that we have m plus n times x, and then we have plus m times n. So this is a real important relationship to keep in mind when we get to the next piece or the next toolkit, which is factoring quadratic expressions, because we use this idea here. But now that we have this x squared plus mx plus x squared plus m plus n times x, easy for me to say, plus mn, we simplify that down to ax squared plus bx plus c. And that we call expanded, or sometimes we call it standard form. So either one of those two ways is how we describe ax squared plus bx plus c. Now a lot of ours, the a is going to be just a value of 1, so it's going to look like just x squared plus bx plus c. But either way, whether you have a number in front of the x squared or not, this is considered our standard or our expanded form. Now, you may have multiplied these things together like I did here. Some of you know a term called FOIL. Some of you use boxes where you set it up this way, and then you just multiply the cross sections. Your x's times each other, your m times your x, then your x times your n, and then your m times your n, and you combine it the same way that we did it before. It doesn't matter how you combine these things or how you multiply these things. You can even break the parentheses apart. I think we've done that before as well. Just as long as you're making sure that all of the things in one parenthesis is being multiplied by all the things in the second set of parentheses. So that's really the most important part here. All right, so let's look at a couple examples. Let's start with x plus 4 times x plus 5. So I'm going to take my x times my x and get x squared. I'm going to take my x times my 5 and get 5x. I'm going to take the 4 times the x and get 4x. And I get 4 times 5, which is 20. So when we combine this, we get x squared plus 9x plus 20. So you see how that kind of relates to that second line for the blue equation here, where we combine these things right here. That's basically what we've done, right? So let's look at another example, x plus 6 times x minus 6. So we're going to start with our x times our x, get our x squared. X times a negative 6, we're going to have minus 6x. And then a positive 6 times x is a plus 6x. And a positive 6 times a negative 6 is minus 36. So when we combine these things, these two cancel out and we're left with x squared minus 36. And as you do a bunch of these, you'll start recognizing patterns, and you'll be able to start doing this quicker and quicker, and you won't have to do the little arrows like I do. But make sure that you have the practice and that you're being thorough about it all as well. Okay, so one more example: x squared plus 6 squared. Now, what this means is this squared is going with the parentheses. So that means that we have to take x plus 6 times x plus 6. So we have to multiply that set of parentheses by itself. So we're still going to do our x times our x and get our x squared, our x times a positive 6, and our 6 times our x, and our positive 6 times our positive 6, and we end up with x squared plus 12x plus 36 after we simplify everything. Now, it's real important that even though we have this squared here, you are not coming up with x squared plus 36. It's easy as we start getting into this idea of shortcuts that we want to do that. This is one of the most common mistakes that people make, and I don't want you to make that mistake. So make sure that you're expanding out, you're setting up your 2 sets of parentheses and then multiplying it across. Don't fall for this trick. It looks very similar to the orange one above, but it's different. It's different at the same time. So you have to make sure that you are expanding everything. So hopefully that helps with the idea of expanding quadratic expressions, and we'll talk to you when we do the next toolkit.